The heart beats about 100,000 times each day. One heartbeat consists of a cycle of events that lasts about 0.8 of a second. Each cycle includes the contraction and relaxation of both the atria and the ventricles. In each chamber of the heart, the sequence of activity begins with excitation. Excitation causes contraction. Contraction increases blood pressure. Changes in pressure cause the opening and closing of heart valves, regulating the volume and flow of blood. Timing of the sequence depends on the amount of electrical activity in the heart muscle. Electrical changes during the cardiac cycle can be seen on an electrocardiogram, or ECG. Electrodes placed on the skin detect changes in the heart's electrical activity. The P wave indicates atrial excitation. The QRS wave indicates ventricular excitation. The T wave indicates the end of ventricular excitation. Atrial contraction, or systole, initiates the cardiac cycle. Phases that follow are isovolumetric contraction, ventricular ejection, isovolumetric relaxation, and ventricular filling. Prior to atrial contraction, the atria and ventricles are relaxed. Atrioventricular valves are open, and semilunar valves are closed. The ventricles fill with blood. Depolarization triggers atrial contraction. Contraction increases atrial pressure and pushes extra blood into the ventricles, slightly increasing ventricular pressure. The excitation triggers ventricular contraction. Ventricular contraction is at first isovolumetric. This means that ventricular blood volume and muscle cell length do not change. Contraction causes ventricular pressure to rise above atrial pressure, forcing the AV valves shut. With the valves closed, the continuing contraction increases ventricular pressure. Ventricular ejection takes place when ventricular pressure rises above arterial pressure and the semilunar valves open. The valves stay open for about a quarter second. As blood is ejected into the arteries, ventricular volume decreases. Ventricles begin to repolarize and relax, ventricular pressure decreases, and contraction ends. Repolarization of the ventricular muscle cells initiates isovolumetric relaxation. As the ventricles relax, pressure in the ventricles drops. Semilunar valves close, preventing backflow. The closure produces a dicrotic wave on the aortic pressure curve. With both semilunar and AV valves closed, blood volume does not change. This isovolumetric relaxation sees pressure drop quickly. Ventricular filling occurs as all four chambers of the heart are relaxed and the AV valves open. As the valves open, the ventricles begin filling with blood. In about 0.2 of a second, blood that has been building up in the atria rushes in to fill the ventricles. Atrial depolarization triggers atrial contraction, forcing a small amount of extra blood into the ventricles, and a new cardiac cycle begins. There are two major heart sounds that make up a heartbeat. They are known as S1 and S2. The heart sounds result from audible blood turbulences of blood flow caused by the closing of heart valves. The S1 sound is described as a lub sound. It's louder and lasts a bit longer than the S2 sound. S1 is produced by the closure of AV valves and marks the start of ventricular contraction. The S2 sound is described as a dup. Its pitch is higher and sharper than S1. S2 is produced by the closure of SL valves and marks the start of ventricular relaxation. The sounds together form the heartbeat and sound like lub-dup.